And all we do is start solving, just like we know how to. I know in a puff of algebra that cos theta equals 1/2. Okay, when is cos theta equal 1/2? Oh, I didn't give myself a solution, like an interval here, did I? Well, okay, that's fine by me. I don't care. Check it out. Theta equals the inverse cos of 1/2. Well, I know that that happens in the first quadrant and in the fourth quadrant, right? When's cos theta? It's pi thirds, isn't it? So pi thirds, that makes it easy. So theta is going to equal pi thirds. Since I don't have an interval, I'm going to go plus 2 pi k. And it's also going to equal negative pi thirds, because in the fourth quadrant, this is kind of nice, isn't it? Now, if I plug in the inverse cosine of 1/2 into my calculator, it's going to spit out pi thirds. That's all it's giving me, because its range is from 0 to pi. Now, let's look at this one. This is a super interesting one. What about cos theta equals 2? Now, your spidey sense better already be tingling. There shouldn't be a big old frowny face going, something ain't right here. You're right. Cosine of theta can never equal 2. So there are no solutions here. You would write theta equals, no, wow, that's just terrible, isn't it? It equals the empty set. In other words, this thing, this half of our work doesn't spit out any solutions. Now, the moral of the story is always check your work, okay? Always check your work. But it's actually pretty easy to do. I know that if I grab these, any values, right, pi thirds plus 2 pi k, it's going to turn this term into a 0. This term can't ever be 0. It's impossible. But it doesn't matter, because 0 times anything is 0, so except infinity, and we'll deal with that in calculus. All right, same thing here. If I take negative pi thirds and then add 2 pi k to that, it's always going to equal 0. So we're good to go. Isn't that a great problem? That one's lots and lots of fun. All right, now I'm going to do one more with you, and I think you guys will like this one. This one's cool. What about this? This is a tricky one. Do I have any room over here? I'm sorry, I didn't pay very close attention. No, I don't. Let's kick over. How about this one? How about if I have to get super clever? How about the sine of, let's go sine theta cos theta equals 1/2. Okay? This one's hard. It's not hard. It's just tricky. You gotta go easy. Let's go on the interval from 0 to 2 pi. I know I'm kind of boring with that, but it's just it's just a variation on a theme if we do for all reals or even on a smaller interval. Now, you look at this and you're like, oh my God, okay. Well, first things first, I might be tempted. I'm going to use the big red pen so that we know. I might be tempted to let sine of theta equal 1/2 and cosine of theta equals 1/2. Well, that's when I bring out the red pen on test quizzes and homework. Wrong. Remember, I can only set products equal to 0, not anything else. So I'm going to have to shuck and jive a little bit on this. But there's a really, really easy way. Remember this guy. Let me change my color. Come on, what's going on here? Remember this? I see sine cos theta, and my brain starts working overtime. I remember that the sine of 2 theta equals 2 sine theta cos theta, right? 2 sine theta cos theta. So let's look. If I multiply both sides of this equation, if I multiply this by 2, which is totally allowable, right? And this side by 2, well, let's see what happens. I'm going to get what? Let's check this out. I'm going to get 2 sine theta cos theta. My stylus is starting to act up. Equals 1, right? Which tells me that the sine of 2 theta equals 1. Now look at what I have. I have one trig value equaling something else. Well, that doesn't scare me. That's fantastic, as a matter of fact. Right? Because I can take the inverse sine of both sides. So I know, but you may say, well, Ripley, wait, it doesn't equal 0. Well, who cares? I've only got one term to get rid of. I can't get rid of sines and coses with inverses all at the same time unless they equal 0 and I can split them up because of the zero product property. But because I've got just this one little sine, sines aren't easy to get rid of, I just take the inverse sine of it. So the inverse sine of 1. Let's think about this. We've got to be real careful. The inverse sine of 1, what do we know it is? So think about sine. Remember, think use all your methods. Sin, Okay, calculus. Let's see, sine, if this is y equals sine of x, I know that it goes to 1 at pi halves, right? At pi halves. So this thing's going to spit out pi halves, which is cool. It's on the interval. There's only one problem. Let's think about that. I'm going to get really screwed up here. I need to solve for theta here. So I'm really going to get theta equals pi fourths. See that? Pi fourths is on the interval. Now, why is that? Well, because remember, sine of 2 theta has a period of pi and not 2 pi. So it's as though I take this guy and scrunch it down by a factor of a half. It just goes and it just squishes it down. Now, I'm going to show you a trick that's really helpful for this kind of a situation. Because you might be saying, Ripley, how do I pick up that second value then? If I don't realize that I'm going to get the value at pi fourths and the value at pi fourths plus pi, right? Because my new period is pi. That's where it gets tricky. So I would get pi fourths, and then I would get 5 pi fourths, right? If I don't realize that, let me show you a trick. Let's just deal for a moment with the inverse sine of 1. I know that that happens at pi halves plus 2 pi k. So if I want to, what I can do, and you can use this anytime, is I can just list some terms, all right? So I'm going to put pi halves in the middle, and then I'm going to add 2 pi to it. So 2 pi, what's that? 4 pi halves, right? So I'm going to get 5 pi halves, right? And then what? 9 pi halves, and then 13 pi halves. I'm just adding 2 pi, which is the same thing as 4 pi halves, right? This is going to be negative 3 pi halves if I subtract 4 pi halves, negative 7 pi halves, etc. Now, bear in mind what we're really looking for is we're looking on a closed interval. Sorry, I just stammered on that one. Now remember, this equals 2 theta. So if I divide through by 2, I get negative 7 pi fourths, negative 3 pi fourths, 5 pi fourths, 9 pi fourths. Now clearly, you're going to get good at this quickly enough that you're not going to have to do this very often. It goes real quick. And then all I got to do is look and say, okay, what lives between 0 and 2 pi? Well, that doesn't, ding, 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 ding. Ah, crap, that's just a little too big. That's just a little too big. So you can just go through and sort of just check off each one of your answers as you go. All right, now tomorrow in class, I'm going to go into some more complicated stuff. I'm actually going to lecture in front of all of you for a little bit. I haven't done that for a while, have I? So we'll have a good time with those, and I'll see you then. I hope you enjoyed the lecture.